set.
Yeah, I guess the moral of the story is get your design patterns right and don't depend on CSE.
Yeah, exactly. Everyone, welcome to the O4S podcast. I am Shasak here with Prashant, and we are going to be talking about microservices today. So obviously it's a huge topic, and we are not going to cover everything. So we'll dive a little bit into that soon. But first, let's just introduce ourselves. Prashant, I guess maybe we can start.
Yep, I'm Prashant Vaghela. I am a part of the engineering team at O4S, and I do have my hands in the platform, the application side of things, and just about everything. And then I'm very capably aided by brilliant people like Shasak and a host of other brilliant folks who I work with. And yeah, that's a little bit about me. And Shasak, yourself?
Yes, I'm Shasak. I'm the VP of Engineering over here. I've been working with O4S for around 4 years now, for more than 4 years. So I've been here basically from the very beginning. So everything we discussed today is kind of my fault. And I'm thoroughly, obviously, like institutionalized here, and I've been here for so long. It is very nice to have Prashant here with us now to bring all the perspective from all the other domains, and really looking forward to this discussion about microservices.
Okay, so without further ado, I think we should dive into the topic. Like Shasak said, that we are going to talk about microservices. But before we actually get into the meat of things, both of us got together and we decided let's talk about this a little bit of a story. So we start from the very beginning. So we'll give you a little bit of a background about O4S and who we are and what we started with and what we did, and then we go on to we did what we did, but then we realized there are some problems, there are some things that would have done better, and then we go deeper and deeper and try to get bits and pieces out, and we see if we can actually solve some of these problems that we basically have at this point in time. And of course, all of this within the original gamut of microservices being a part of this entire conversation. So let's see how it goes. This is the first time we are doing something like this, so please bear with us. But
we are very, very new to this. We are new, as you would call. So before we dive into anything, I'm supposed to sort of implore you guys to like and share this video
and subscribe.
Also subscribe for future content about all exciting stuff that we're doing at O4S. Okay, so I guess we'll start. So first thing we want to cover is something sort of give everybody an overview from more like an engineering perspective. Mm-hmm. What O4S is all about, like what are the core ideas behind what we are trying to do, and that should give you a nice bedrock to build on top of it. So I guess we will start with what we do as a company. So the original idea of O4S was that it started as an anti-counterfeiting company. So we were basically trying to integrate with manufacturing firms so that we could establish a digital identity for each unique asset that they manufacture. So just imagine any manufacturing plant. So were there any goods that have been manufactured? So far they were always tracked in batches. When we come into the picture, what we do is we are able to actually serialize individual assets with their unique identities. It's kind of like an Aadhaar card for like every unit that gets manufactured at that manufacturing facility. And since it has been encoded with a barcode or a QR code of some sort, it is now digitally usable in the sense that people can scan it. And as they do that, certain activities against this asset, those activities can be tracked. And this is what our platform is all about. We are tracking all of the activity that is happening against a particular asset and attributing it against that asset so that we can build use cases on top of it. So that is the bedrock of our platform. This is one of the harder problems that we solve, which is actually integrating with manufacturing companies, being able to individually serialize their products. So I guess that's a good enough brief introduction of what we do. So on top of this bedrock of UIDs that we have, and we are sort of establishing all these applications on top, which are basically solving various use cases across the supply chain. So since this is a very fundamental thing that we are doing to the product, basically digitizing the asset, we can build lots and lots of use cases on top of it because it's a very rich source of data. So all kinds of data-driven use cases can be built. So we are solving use cases across manufacturing processes, so helping companies understand and be more accurate with their manufacturing processes.
Yeah.
We are helping companies track their products across their supply chain, so the distribution of their products and the sale of their products, they are able to track via this particular platform that we are building for them. And simultaneously, we are also able to engage with their retailers through trade promotion programs, and with their consumers, end consumers, you and me, who can actually verify the products and know their authenticity, where they are coming from and what kind of places they are.
In a nutshell, we are trying to solve a problem that has been lying in this industry for ages.
Yes.
Visibility.
Yes.
Right? Everything is dependent upon visibility as far as supply chain is concerned. Now, it is a well-known fact that once manufacturing company or FMCG manufactures something, post the jurisdiction of the plant, they lose visibility by far and large. Now, when you lose that visibility, then whatever happens post that is guesswork at best.
Yes.
Now, whether it is trade or promotions or distributor management or retail management, or for that matter, even manufacturing forecasting, even that is basically based on numbers and data which is available from some place, from here, there.
Manual data entry.
Yeah, data entries. There is no real basis for a factual information on the basis of which they can actually do their decision making for manufacturing as far as manufacturing is concerned. So that's the bedrock and that's the platform that we have, and on top of that, a whole load of use cases get solved, and counterfeiting, like Shasak said, is a very important one. So having said that, we go into the description of the platform in general, and then how we started off with and what influenced our design as we basically set on this mammoth task of modeling this very intricate domain onto a service as a software as a service kind of a platform. And and so now we'll talk about how we broke it down, and then what kind of a pattern that did we employ, and then we will go forward from there.
Right. So initially, since we were more focused on the, you would say, counterfeiting aspect of things, that's where we started our journey. So we were a young company. We didn't have that many clients, and clients were usually belonging to certain domains in the beginning. So initially the system was sort of designed to just meet the immediate requirements, because everything was new to us. We don't belong to a manufacturing background. We don't know much about what goes on there, and we had to learn as we go about what's happening in that domain. And soon enough, we found that there are lots of things that we don't know, and there will be in future many things that we will not know. And at the same time, this is a domain where there's a lot of variability and configurability required, because every different manufacturing company has their own processes, their own way of manufacturing their goods, various levels of technology adoption. Some companies are super technically advanced and they have adopted the latest and greatest tech. Others are still lagging behind. They don't even have proper internet connectivity at their plants. So especially speaking about where we are operating, which is in India, there's a lot of companies that have all this, across the entire spectrum of technological adoption, as well as manufacturing process updates. So as we got to know and got in contact with more and more clients, we realized from an engineering perspective that this system has to be extremely configurable for it to be usable by companies at large. And if we want to go into the SaaS domain, we are actually fighting against a software which has so far always been hyper customized specifically to their specific needs, which is the ERP software systems, which are, they have an entire team of people just to customize to their needs that particular ERP system. Whereas what we are trying to do is break away from that paradigm and have like a very simple and easy to use system which you can just deploy and start using it across the board.
Customized plugin use.
Exactly. So that was the chief engineering challenge initially, and in the beginning, because everything was moving so fast, we started with a very monolithic system. We basically had like this one major database with one major collection, and we were using a NoSQL database for that particular reason, because we didn't know what attributes, what kind of schema, how it's going to evolve. We had no idea. So we started with Mongo and we went into the document store, and we had this monolith system that was just tracking inventory and tracking transactions by consumers against that inventory. Rest of the use cases we had not yet figured out.
Yeah.
So we were just working on those two ideas. And then as we learned about this problem, we started to see that this cannot hold for too long, and we started getting into other use cases, which was like provenance, basically tracking the product across the entire chain, and trade promotions, which was another big one, which had like lots of use cases in and of itself. Trade promotions in itself is a huge domain, and obviously it had to be built on top of this asset attribution system. So it was initially done at high speed in a single service monolithic kind of thing, and that's where we were initially.
Right.
As we progressed, we started to realize that this is not going to do, and we will have to split up at least the TPO, the trade promotion side, and the inventory side, which is the manufacturing and inventory side of things. So this is where the word macro service kind of comes into the picture, which is that we didn't do microservices right away. What we ended up doing was more like two big services.
Yeah.
One is for like just doing the trade promotion side of things, and one is for handling at that time, even the consumer side and the manufacturing side of things.
Yeah, like a mom service and a pop service.
Right, exactly, something like that. And so I guess what we can now discuss, Prashant, is like why we did not go straight up into microservices. Let's break everything down into small services, and went into more like a macro kind of system, which will be sort of like discussing the advantages of a monolith. And guess what? Monoliths have great advantages.
Yeah, truth be told, monolith service does have its charms. And there's a reason why it's there.
Exactly.
And a lot of people, a lot of companies, and a lot of massive architectures still use monolithic services.
Yes.
So yeah, we'll get into why we did what we did. See, if you think about the supply chain domain, right, and the domain that we basically are in, take a bar of soap that is being produced by a manufacturing industry, right? So once the bar of soap is produced, and we want to give it a very distinct digital identity, there our involvement starts, right? In many ways, that's where our involvement starts, and so we basically provide some kind of serialization, digital serialization to that particular asset that you would call an SKU or a product or whatever it might be, whatever you may call it. And once that happens, and from a domain perspective, this bar of soap is still on the shop floor. It has been given a digital identity, but that identity does not mean anything at this point in time. It has not changed its avatar, its state in any state or form. Once it starts moving away from the manufacturing floor onto a warehouse to a dispatch to a warehouse to a distributor, to a retailer, and eventually until you buy soap, all of that, every single stop on its way changes its state. Now, when it changes state, doesn't change state in its physical form, but then the qualifying attributes of that particular SKU will change. Now, and that you could basically take this storyline across the entire supply chain. The trick is to see it and to see its movement, and the problem comes in because there are so many state changes that are happening and full state changes that are happening. Comes that design thought in the head that how are we basically going to start off with manufacturing, then provide serialization, then track its state change across the entire journey of that particular product. And while we are doing this, we are constantly interacting with some kind of a source which is keeping track of the source, which is keeping track of the state change. And to Shasak's point, a monolithic kind of an infrastructure where if you can visualize every single asset or product that's manufactured as one document, साबुन बनाया एक पेज खोल दिया, as the state changes, you start making entries. This is the first entry, second entry, third entry. Oh, reach consumer, last entry, document closed, done, SQ over. Now, if you think about it, a monolithic architecture and infrastructure there makes wonderful sense.
Yeah.
Right? And it has many advantages to it. Anyone can come and write into it, anyone can pick it up from there, and whatever, come what may, it doesn't matter. So, multiple applications, multiple things, services can all interact with the same single infrastructure, and it all works.
Yeah.
It works. And so, for our scale at this point in time, it does work. And but there are problems, and then you want to talk about some of these problems.
Yeah, so I think I couldn't have described it better myself. I think that is the challenge with this domain. Like, so it is very intuitively making sense that, let's open one page and put everything inside there. But what started happening was that, as we talked to more and more people, new use cases kept coming up, right? And people were like, okay, why don't you do this in trade promotions? And why don't you do this in supply chain tracking?
Yep.
Why don't you do this in manufacturing? Since you are doing such a fundamental thing, which is, you are serializing the individual asset, there are so many things that you can do and that are actually pertinent use cases to all these companies that nobody else is doing. That they're like, okay, since you have an individual UID, you can do this also, right? So why are you not doing this? And the thing was that we didn't know at that time what O4S was going to become. Right now we have some clear picture of we want to be a platform.
Right.
At that time we were thinking not in those terms, right? But obviously the platform was building itself, right? Because everybody is thinking about us in terms of this sort of bedrock कि okay, अगर मैं एक manufacturing company हूँ और मैंने अपने सारे UID को serialize कर दिया है, तो अब मैं एक use case सिर्फ solve करूँ, that does not make any sense. Why should I not solve all the problems that this can solve for me?
Yeah.
Because it's such a huge investment to do this in the first place, right? So they started giving us all these feature requirements and all these things that okay, we want this kind of stuff. And then when you think about that single page and all these different feature requirements, it becomes very difficult to bifurcate and sort of allocate and scale and think about, even reason about a specific requirement, right? Because every time everybody is touching the same page, so it's possible to disrupt other people's use cases at all times, right? So that's wherein we started to decide ki okay, this is getting a little out of hand, and especially when it comes to engineers working on a piece of software, it was becoming very difficult because if everybody is touching the same thing, it's inevitable that things will crash and burn.
Absolutely.
So we decided to say, okay, at the very beginning, we need to start adopting this microservice architecture because for us it makes total sense.
And the core important part as far as engineering is concerned for this monolithic, for this use case, forget the monolithic infrastructure, for this use case is atomicity.
Yeah.
And idempotency is lies at the core of its operations. If you have an infrastructure which is like we just talked about, a single page where multiple people, services, macro services, come what may, are making entries in the page, to maintain atomicity and idempotency becomes a challenge. Now we no longer can be, swashbuckling gunslingers जिसको जो करना है करो. Everyone has to keep track of भैया तुम क्या कर रहे हो, मैं क्या कर रहा हूँ. So that sanity is maintained and integrity is maintained in this massive infrastructure that we have.
Right.
So and well then there is cost, because right now we start off with 5 clients and then we go with 2, 10 and then we go to 50 and then something like potentially what if a Unilever comes in with 100 million ka scale and then this infrastructure explodes and then explodes right onto our faces and then we don't know what to do. So there's cost, there is, and of course as this infrastructure increases and bloats up, there's latency, because there's also one very important use case that we have faced recently, right? Where everyone, you have a massive long document for a particular SQ tracing our journey. Someone from operations says, I want to figure out what you guys did to this particular SKU at this point in time. Now trying to come back to this massive page and trying to extract information, give it to them in the form of a report is a nightmare. And we have faced these nightmares, right? Day in and day out. And that basically makes it an difficulty point that we have to address when we have infrastructure to this, because then because for whatever reason we have catered to one part of this business, which is transactions.
Yeah.
Every other byproduct of this transactional business that we are in, the core monolithic transactional infrastructure is not going to cater to it adequately, at least adequately. It can, of course, with a lot of magajmari and bejamari, of course it will. But so then we will need to think about doing things a little smartly so that we can maintain our states, change our states, reduce costs, not inflate, not have it blown on our faces, maintain developer sanity.
Which is, I think, a huge point that people miss about microservices, that developer sanity is a huge thing, because if your developers are not able to confidently edit code, then they will not be able to ship code fast.
Absolutely.
And if you are in a startup ecosystem, trying to enter into a domain that is, relatively sort of, people already fear this domain. They don't.
Why it's not compromising on speed?
Why is not? We can't compromise with speed because their manufacturing cycles depend on us.
Yeah.
So even though it's very hard to keep up because the requirements are just so many, but it's still, if people are able to make sane decisions about a small piece of thing, then it's so much better, and we can have like responsibility, ownership of those things, and make people sort of the owners of those services, and they can independently do their development, right?
Yeah.
Which all makes a great sense on paper, but when you try to actually break a monolith into its subsequent services, microservices, there are a few things that come into the picture that you have to keep in mind.
Yep.
And I guess I'll start with some of the things that we initially faced from going not even into micro but even into macro services. We were facing problems. So one of the major things is that when you are trying to break down into microservices, the only way to achieve independent scalability is to also separate state.
Yep.
So you have to do state separation. So just to give an example to people who don't understand that, if you are all operating on the same database, no matter how many microservices you have, your database has to scale for any of those microservices to scale. So in effect, that microservice cannot scale independently. So if you want independent scaling and independence in that sense with the developers also, like, I want certain resources for my service, then there has to be state separation. Otherwise, they can't scale independently. So when you think about state separation, it becomes a big problem in terms of tooling. And how do we ensure that the use cases that we're trying to solve, the feature that we're actually trying to build is, since we are now separating states into multiple microservices, nobody thinks in terms of microservices. The product team is not going to think in terms of microservices. The clients don't think in terms of microservices. They think in terms of features. And a single feature could be affecting 5 services. And it might have atomicity requirements. It might have communication requirements between multiple services. And then you have to build this communication framework. Okay, how will you communicate with my service? How will I communicate with your service? So as soon as you step out of that monolith land, you are suddenly talking about services rather than libraries.
Yes.
Libraries are easy. You can say version 1, आज मेरे पास एक library का है. कल को तुमने version 2 release भी कर दिया. But since the library ships with my code, I can continue with version 1. I don't have to worry. But in a service, that's not going to be the case. It's going to be whatever is the version of the service right now. So it's like a third-party thing, almost, right? So when you do that and you do state separation and you have to think about it, it becomes a very tricky choice. Like, how do you do adequate state separation so that if you ultimately end up doing it in such a way that their service A is always dependent on service B and service B is always dependent on service A, then you have coupled them.
And then you have bottlenecked.
And then they can also not independently scale. So it's not making any sense.
Right.
And you have added all this extra tooling for communicating between each other, which you were doing inside code in the monolith, which is so much better. Right?
Yeah, which is, coupling services is another whole new mess by itself, because the communication between these two services has to be exactly one semantic driven, because one service is dependent upon the other one. So if this fails in between, your entire state change operation goes down.
Exactly.
That is, forget about scalability, that becomes a nightmare to even operate.
So inter-service communication is something you want to always reduce as much as possible. It's a good indicator if two services don't interact that much or are not bi-directionally dependent on each other,
Yeah.
then it's a good sort of indicator of okay, you have done state separation in a nice way.
Correct.
But that is a art, it's very difficult.
It's an art, and at the same time, you also have to remember that while these services are not dependent on each other, there is still the concept of idempotency in states. So certain states will happen only when previous states are done.
Yeah.
Now you still have to maintain that paradigm because that is the name of this use case. That's what the story is about. Now, technically, in the service architecture, you don't do it making service dependent. However, conceptually, you still have to maintain that stateful order.
Which is hard to do if you're talking about microservices and you don't have a proper paradigm in place to do it. Because then the engineer has to really, sit down and put his head against all these services, how they're interacting, ensuring atomicity, two-phase commit, what all you might have. So it's very difficult. Then in effect, it sort of neutralizes the benefits of the microservice architecture itself. Because now one person or two architects have to treat 5 services together, right? So you didn't want that in the first place. You wanted independent ownership.
Right. So the first thing that and quite honestly, I and Shasak, we basically went through multiple iterations of thinking of this thought process, Macroservices, monolith, macroservices जो अभी हम लोग कर रहे हैं, हो रहा है. Problem है, we just talked about this problem, there are problems there. Then we said, you know what, let's start thinking of microservices. Then the first obvious thing that comes into place when you think of stateful behavior, यार एक काम करते हैं, let's model each state of the SKU. We will have a service integrating with each state. And let's make each one depend on the other. ये होने के बाद ये होगा, ये होने के बाद ये होगा, ये होगा. Then we started doing, if you do this, then we basically need to have a communication protocol and a pattern in between all of them. Then if one fails and the entire thing fails, then you need to have proper fault tolerance and semantics, exactly one semantics and delivery semantics and all that kind of stuff. And then we will need to start breaking them down into the individual stores and have communications between them and all of the kind of mess.
So let's do one thing. So this is one aspect of the services. State separation, we already discussed that state separation is a hard problem.
Yeah.
It's not straightforward. And in fact, in many interviews, I have candidates who have come to us and they have told me that okay, in our company we are doing microservices. As soon as you start asking about state separation, you find out that they're actually not doing microservices. So it's a very tricky thing, and it's a very interesting thing. I will dive into that later, and we'll even discuss what we are planning to do in the future to solve some of the problems we are highlighted right now. We want to do we want to first touch upon, I guess, an interesting thing to discuss would be like how code organization and sort of gets disrupted, deployment patterns, CI/CD gets disrupted from going from a monolith to this system, and how you have to deal with it also.
Once you talk about this particular part, then we will talk about a potential pattern.
Yeah.
A potential pattern that can work with microservices, maintaining states, atomicity, idempotency, and can make code coverage and code delivery a lot more exclusive. That is what we want from the engineer's perspective, right? So we'll talk about that.
Yeah.
Cool, awesome.
So I think this is a more, I would say, to our viewers, this would be a problem that is more universal. No matter which architecture you choose, what pattern you're using, you will always face this problem from going from a monolith to a microservice system. Is code organization. How does the code get organized? How does the CI/CD get set up? So starting from a very basic example. So like say for example you have a monolith, right? And you decide to break it into 3 services, okay? And let's just say that you are some kind of a god and you just did a really great job with state separation and all that. Awesome, good on you. But now what happens is, okay, you might say, alright, what I'll do is I'll have 3 repositories of code and 3 teams and they'll be managing their independent code and so on. However, like we discussed just now, inter-service communication, depending upon your design, how much inter-service communication is necessary between these services, how much work they need to do together, what kind of state objects they are manipulating, and obviously if in our use case, supply chain use case, there are rules like if state has not reached this point, then it can't go together.
Exactly.
That kind of rules. So if you have to do that, that means you have to have inter-service communication. And if you want to do a lot of inter-service communication, then you have to set up, okay, you are working on service A in your own repository. You have your own version 1.5, whatever, right? I am working on service B, my version is 1.6 or 2.5, whatever. you are working independently, I am working independently.
Right.
You change your version to something, and you might have introduced a breaking change. Right? How does this get communicated to me? Right? Now the easy answer is okay. We will obviously have end-to-end tests written, and all smoke suits and everything will be in place, and we'll be always green. But we all know that in a high-paced atmosphere, that is not always reliable.
Yeah, 100% regression is not really
Exactly.
an achievable state.
Exactly. 100% to कभी भी नहीं पहुंच पाओगे, but even if you have a good culture, you will still have, you can't rely on that process. You can't always be sure, in production one day I am not having two incompatible versions.
But at best it can be just communication process driven, which
Yeah.
is prone to failures in any case.
Exactly. So you are dependent on, in short, Slack or email to communicate, bro, I broke this interface, you have to update your service. And that guy has to somehow do that. And the important crucial point here is that it is moving outside the domain of code.
Yeah.
So one of the ways we solve this problem was, and this is also inspired by one of the ways in which many other companies are solving this problem, Netflix, Google, Microsoft, all these companies, is by identifying contexts and bringing those contexts under a single repository and thinking of microservices as a deployment pattern rather than a coding pattern.
Correct.
So we are writing code as if it's a single monolith, but we have these different parts that are deployed independently, right? So that way it's all in a single repository, and there's only a single version, which is the crucial point, that our entire ecosystem has a single version against which everything gets tracked. So developers can go back to the old model of delivering features rather than delivering service deliverables.
Correct.
So they're not thinking in terms of मेरी सर्विस में ये करना है मेरे को. They are now thinking मेरे को ये फीचर बनाना है, तो इस सर्विस में ये करना है, इसमें ये करना है, इसमें ये करना है.
Breaking changes are automatically going to be reviewed,
Yes.
peer reviewed, and merged accordingly.
Exactly, because they will show up in your VCS, which is
Exactly.
the easiest way to sort of make things work together in a good fashion. So
Yeah.
this is one of the things that happens when you go from monolith to microservices. You have to keep that in mind. Like, how do you do this code separation? This is again a problem like state separation. Like, if you do code separation, you are separating your organization. So you're separating your organization that has it. So everybody knows that there are problems there.
Yeah.
Like, how
Yeah.
will they communicate? Who will be the authority in deciding what goes into production? All that stuff, right? So you have to think about those things as well. One of the answers is figuring out monorepos, maybe a couple or 3 monorepos that you have with all these services that are kind of working
I guess
together.
the holy grail is that how do you kill the gatekeeper? You don't need a gatekeeper.
Exactly.
How do you not have a gatekeeper?
Yes.
And that's the name of the game, and that's what
No
we
central
think.
person like
Yeah.
who's like responsible
Yeah.
for everything. कि कुछ भी होता है production में तो तुम्हारी गलती है.
Yeah.
That should not be the
We
case.
don't want no gatekeeper here.
Exactly.
Thanks.
And we especially don't want to put pressure like that on any human being.
Yeah.
भाई nobody can do this. This
Yeah.
job is setting a person up for failure. कि तू होएगा किसी दिन फेल पक्का और उस दिन तेरे को डांट पड़ेगी. So it's just kind of like that. So we want to avoid that at all costs. We don't want to treat our engineers to this kind of a situation. So in order to avoid that, one solution is monorepos. Now coming to the second problem, which is you have to now track, like for example, there are multiple services, right? And they have to communicate with each other still. And the communication problem is not going anywhere. You still have to ensure communication. And you have to track versioning, which we have to track against a single version and all that stuff.
Right.
Now you have done all that, but what about deployment? So if you look at any CI/CD tool, any CI/CD tool that is available today that is popular, you will find that the monorepo system में आपने ये जो problem solve कर ली, they are lagging behind. They don't recognize monorepos as first-class citizens in their tools yet.
Yeah.
Right? They have built all of their tools. In fact, even Git itself is not particularly suited for really large repos. It starts breaking at some point. Even though they have introduced some things like submodules and stuff like that to deal with these things, but still, there's a lot of problems there that are unsolved. So obviously, that's a cautionary point that you are venturing into an area that is a little bit untapped. And all these big companies have a lot of engineering force behind them, so they are able to build their own internal tooling around these things. But you might not necessarily get your tooling in that place. So you have to then write scripts and sort of have in the CI/CD toolchain the simple aspect of okay, chal Travis CI लगा देते हो गया CI/CD.
Correct.
That you can't do
That
anymore.
can work.
Yeah, you have to track things across multiple services. So you need to have some sort of setup. And not to dish on like the CI/CD tools, they have provisions for monorepo.
Yeah.
But it just feels like an afterthought. Doesn't feel like from the ground up they have decided to cater to microservices as tooling is as far as
Because they didn't come from the background, right?
yeah.
They never came from that background, and
Yes.
then gradually those problems have not been seen by tool sets like these to come to a brand new set of problems which are occurring right now. They came here and so they solved this.
Yes, exactly. So they're catching up, but I guess cautionary thing is that you have to be ready for that.
Yeah.
You have to accept that okay, this is going to happen. So I need people who can write the glue code between these tools and your setup, monorepo setup.
Yeah, I guess the moral of the story is get your design patterns right and don't depend on CI/CD only.
Yeah, exactly. Don't entirely like जो वो बोल रहे हो वही करके तुम अपना डिजाइन मत बनाओ, अपना डिजाइन उन पे इम्पोज करने की कोशिश करो.
Correct.
Which is great. So yeah, this is the other problem, which is like DevOps suddenly becomes a slightly more difficult thing to do.
Yep.
And obviously we ended up adopting. We were initially always from the very beginning we were a Docker shop. Everything was a Docker artifact, so we wanted to have a very smooth CI/CD process where they don't need to worry about which programming languages people are writing code in. Everything is a Docker image, so the DevOps guys can deploy independently.
Yeah.
And we were initially using Docker Compose to deploy everything, and obviously we had like a couple of servers on which we were deploying. But then we saw, as our services grew in numbers, that the need of an orchestrator kind of became apparent.
Absolutely.
There has to be somebody, something, some tool orchestrating these services.
Dependency management becomes a nightmare otherwise.
Exactly.
Absolutely.
And like if you want to scale, then like how are you going to indicate किस service को कितना replicate करना है, at what replication factor each service is supposed to run, all that kind of stuff, like what resources, resource injection, like secret injection, all that stuff has to be taken care of within that framework, right? Because there's so many secrets now, so many services, so many different secrets, so many different constants that need to be shared. So
and remember these multiple services, even though we have gone away from this massive thing broken down into microservices, they still are reliant on one single monolithic data infrastructure. So rate limiting across services, किसको कहाँ rate limit करने का है, कितना करने का है, कितना ये load संभालेगा.
Exactly. So that's the reason why we decided that we had to get an orchestrator of some sort.
Right.
And we were initially looking at Docker Swarm and Kubernetes and another one by HashiCorp. It's called, I think, I forget the name, Nomad. So these were the candidates that we had sort of gone through for our POCs. And at that time, with the whole CNCF gung-ho going on, we decided that all of our needs are going to be satisfied by Kubernetes, I think, for the foreseeable future. So we went ahead, and now we have a architecture that is based on Kubernetes. Everything is deployed on Kubernetes using Helm charts and all that stuff. And obviously all the monitoring and everything that is the standard pattern in the CNCF domain, like Prometheus, Grafana, all that stuff.
Correct.
Kibana, IKS. We ended up doing that, which is absolutely necessary if you move to a microservice architecture.
Correct. Telemetry is, without telemetry, the services don't work. I mean, they might, but then we don't know whether they work or not.
Which brings another thought to mind, another problem with microservices that is inevitable will come, is since you have broken down into different services, when a request comes, it's no longer a single request.
Yeah, that's right.
So you have to do distributed tracing now.
Yes.
You need tools like Jaeger or something like that to track your request against all the services where it goes, and it affects, because you want to audit what happened in the real world that led to this state in your system, and what happened along the way needs to be traced. Right? So in our particular domain, it's absolutely paramount that we do that, because we have to give audits to companies.
Yeah, drawing the line is very important for us.
Exactly.
We need to know where that line broke.
Yeah, exactly. And not just even from a debugging perspective, because usually this is talked about only from a debugging perspective, but for us it's like absolutely paramount to give to companies also, because they want to know the authenticity of their data.
Correct.
They're like, how did this happen? How did this happen to my data? My customer is seeing something random on his mobile screen when he scans my product.
Right.
Who did this from my side? Like if somebody...
See, you also have to understand, because all of this depends upon, all of this is very heavily going to weigh on their manufacturing, their products getting out of the market, and it is also going to very heavily weigh on us getting our money.
Yeah, exactly.
So उनका छोड़ दो, लेकिन हमको पैसा नहीं मिलेगा.
Exactly. So
it's very important.
they will be like, since you can't tell us why this has happened, this is your fault.
Yes.
So we have to be able to tell them that
Exactly.
no, actually somebody did some manual data change or something like that, or some SOP was broken because of which this data is this way,
Right.
and then we need to do adequate correction methods that we have built. We need to employ those. So yeah, that's the other problem. Distributed tracing sort of becomes, in your particular use case, it might not be absolutely necessary, but for O4S, it has now become absolutely necessary that we track everything across the board, right? So that's the, I think, sort of covers all the problems that we have faced so far. Now, I guess we can hop back to the data problem.
Now we can go to the possible
the crown jewel of problems.
Yeah, the crown jewel of problems.
Yeah, so just to sort of briefly go over it again, I think Prashant did a great job of explaining it before, but I'll still go over it once more, which is the problem of atomicity, right?
Mm-hmm.
And the problem of also being able to have organizational flexibility. That independent services should be able to, work independently without having to do, checks and balances against every services code. Like, tu kya kar raha hai, tune kya change kiya? I don't need to do that as long as there's some system that enables me to work in this way. So I guess immediately the thought that comes into people's mind when they talk about a system like this is event-driven design. Right?
Correct.
So that my service is always thinking about events and it does not care about your service.
I don't care about you.
Exactly. So just give me the event that I'm interested in and I'm happy. And that is, I guess, the central aspect of event-driven design. I guess we'll just linger here for a bit. With event-driven design, just to not confuse. So, like, simply because you're doing event-driven stuff doesn't mean that you're decoupled. It could be so that your events are sort of modeling coupling only, right? So you have not designed your events in such a way that it allows for flexible development on top of those events. Because those events are so specific to the two services interacting with each other that nobody else can use that event.
Correct. You've destroyed the dependency paradigm right there. And if you destroy the dependency paradigm, then there is no point in doing this.
Exactly.
Because that's exactly what we want to get rid of.
So simply because the thing that is that many times again, in interviews, people say we are doing event-driven architecture and all that stuff. And then you start digging into how is this service doing this?
And then we are doing event streaming.
Exactly. Just such a specific event that nobody else can, deal with it. So that's another challenge, which is like, it's a very easy to fall into trap. Because we have been developing software in this sort of request reply pattern for so long that it becomes very difficult to sort of change our minds about what is an event. Thinking of an event as just like a message passing thing has to stop. You have to move to thinking about the event as an architectural artifact. This is central to my entire architecture, not just to this particular service. Which is where the concept of domain events sort of comes into.
In fact, a more poetic way of putting this is the definition of the event itself lends heavily on the design pattern. You don't think of a design and then everything else that fits into it. What fits into it? That small pattern piece itself. Because you want to maintain its identity, its atomicity, its idempotency, all the way through till its culmination, that itself gives rise to a design pattern. Right? And that's the pattern that we actually want to talk about today, because that's the pattern that is a pattern which is going to potentially give us infinite scalability. It is going to give us atomicity, idempotency. It is going to give us stateful behavior if we model it right. It is going to give us code independence, developer independence, and peace and mental bandwidth. It is going to help us deploy much easily, and our system is going to be a lot more flexible because these are all independent domain events. आज 10 पकड़ लो, कल 100 पकड़ लो, कल 1000 पकड़ लो, फर्क नहीं पड़ता. प्रोडक्ट को 10 फीचर और लेके आने के हैं, इसका मतलब अपने को 10 और डोमेन इवेंट्स के बारे में इनकॉर्पोरेट करना है. No issues, boss.
Precisely.
कोई प्रॉब्लम नहीं है.
Absolutely. So I think that's pretty much what domain events are about. So if you're coming from a background of DDD, domain-driven design, So this should be totally familiar to you, that you don't define your architecture based on engineering chops.
Yeah.
You define your architecture according to what the domain is telling you. So usually your domain events will actually be understandable by people in operations and in product team.
Yeah, the business will understand it.
So it's a good sort of indicator that if your event is not understandable by somebody outside the engineering team, then that's a bad event. You are probably doing some weird coupling thing, and you are no longer in the realm of domain events. You're not in the domain anymore. You're in the architecture.
You're an engineering event. An engineering event is not readily understood by everyone.
Exactly. So just to give you a small example, like think about, like for example, a domain event would be user added. User was added into our system.
Yeah.
Everybody can understand that. But if I said something like service B do this, and this is an event, this nobody can understand, because what is service B? What is this? Oh, a push service send SMS, right? How does this person know what does the push service do? What does SMS mean? All that stuff. They don't have to worry about any of that stuff.
Yeah.
This is an example of coupled event. This is very specific to me talking to the push service, has nothing to do with the domain.
Yeah.
Right? So you don't want those kind of events.
वो कहीं भी हो सकता है, यहाँ पे हो सकता है, यहाँ पे हो सकता है, कहीं भी हो सकता है.
Exactly.
In a supply chain context, a domain event would be product is manufactured.
Yeah.
तुमने label लगाया, किसी ने इसको scan किया, उसको activate कर दिया.
Exactly.
Distribute उसको, then you basically dispatch it to a warehouse. Warehouse said, I received the order. Code gets out of the warehouse, sends out to a distributor. Another order is created. Okay, go to a distributor. Distributor scans it, says, I received your order, I received the product. So now the state of the SKU has changed from being in inventory in warehouse to basically being in inventory in distributor. And then to a retailer, then to consumer. Now a business guy understands it because that's a business.
Yes.
And that is the domain event we're talking about.
Exactly. So it's I think a very good hint that just ask your business manager.
Yeah, exactly.
Right, dude, I'm making this event. Does it make sense to you? If it does not make any sense to that guy, then it's probably something is missing out.
Wait, याद है years back when there was this massive debate about this 3NF modeling,
Yes.
ERP 3NF modeling, and then people started writing SQL queries, not understanding business kya hai, because those enterprise relationship diagrams were so convoluted that no one but the designer and architect knew about it. Yeah. And then Kimball came and said, no, I want to dedicate my data models only on business. So, very similar kind of a pattern here.
Exactly. I think a good data model is also a reflection of whether or not you understand the business.
Absolutely.
If you don't understand the business, your data model will look some half as
it has to mimic a business.
Exactly. All the names, I am actually a huge proponent of I obsess over code reviews what is the name of a thing.
Yeah.
I totally obsess on that, because to me it's a huge hint key whether or not the developer has understood the domain. If he's naming it something stupid, I can totally get that he's mixing two concepts together, there's something wrong here, and he's going to end up doing some big, massive, not on that day, but some other day. He's going to do a massive, bug into production kind of scenario, which is hard to track because now you can't even read the code. It doesn't make any sense to anybody else. It's like some weird thing that is in only his mind and nobody else knows about that. So just as we obsess about names in our programming, in our code quality, this you can think about as a architecture quality survey kind of thing, where you just always have somebody looking into the domain events and like, oh, this event makes no sense, has to be something else.
While I do hold this firmly in my heart, and you're going to be a very difficult person to live with, I still do completely agree with the concept behind it. I know it makes life difficult. Yes.
Yeah. I mean, it's like one of those things that pays dividends over time.
Yeah,
so it's not easy for people to see कि ये कैसे अपने को help कर रहा है.
Correct.
But when you one day somebody comes with a new feature request and you have a nice domain event that immediately solves that problem, and you just write one service, consume this event, convert another event, you're done. Then you feel good that you did that thing.
You want to sketch something out for people who are
I was meaning to, but like speaking and sketching at the same time is becoming totally difficult. But I'll try.
Yeah.
So anyway, I guess we sort of covered the importance of event-driven design, how event-driven design is not necessarily always realized, and then what a good domain event is. And I guess now we can move into subsequent problems, which is the problem of how do we ensure that across services there is no need for 1:1 communication, and services can interact with each other. So the central bus idea. So I guess we can start with the definition of the name of the architecture.
Sure.
The name of the architecture is event sourcing. I'm sure many people must have heard about it. I think Martin Fowler was the first person to sort of come up with it and sort of popularize it, I think. But I'm sure like some version of this is going on in many places.
Yeah.
And I think one of the key technological things that has happened in the recently is the huge adoption of Kafka, and the near exactly once guarantees that Kafka is providing, which has sort of made this a very viable and feasible thing for organizations who really need a good audit trail, and they need this sort of central bus and all these other applications sort of independently being built on top of a central platform.
Correct, because this entire thing is very clearly hinged upon surety of delivery.
Yeah.
If your delivery of messaging is not assured, then this falls flat.
Do you want to jot something down?
No, well, not really. I just wanted to make a point that it's all dependent upon assuredness of delivery, and that Kafka does offer that to you too, and so now it's a more feasible option that we are actually sitting here and talking about it now.
Yeah. So okay, I guess what we'll do is like briefly walk over the event sourcing core concept, like what it is, why we want to adopt it. Okay. So I guess we'll start with the traditional stuff. So like say for example, you have all these services, right? In a particular ecosystem, you have all these services, and they want to. Usually, what would happen is that some service is listening to the user side event, and that service is basically the application facing service, and it has to then interact with these other services on the platform side that it needs to do work with. Now the simplest way is that you build direct communication between them, which is what we discussed earlier, which is what is happening in many companies, is that they're just directly communicating with each other and in a request reply sort of fashion, request reply. And it is the traditional way of doing things that is basically not giving you the benefits of microservice architecture, because you are just always having to think about both services together.
Right.
Then comes the subsequent model, which is okay, what we do is we do event-driven design, where what we are saying is, okay, I am this guy S1 and I have this queue of sorts, and in this I send an event, and then there is another guy S2 that listens to that event, and in another queue there is another guy to whom I also communicate my event, which is the other service. And then based on this calculation, I make this service might send it to another queue that I am listening on, and so on, right? So I will eventually end up fulfilling this particular request, right? This is the second part that we discussed, which is that again, this event is too specific, right? It is going too specifically from S1 to S2. This could be the kind of event, okay, please send an SMS for me kind of event, or please calculate the mass of this particular thing kind of event, right? Or calculate the ownership graph of this, please, for me. Something like that kind of event, which is very coupled again. It is not, I can't use this event because these two people have been, conniving together. And
they're married to each other.
Yeah, and this guy doesn't have any idea what's going on. He's like, मेरे को तो इस तरीके का event चाहिए, E2 टाइप का चाहिए, और आप लोग E1 भेज रहे हो, तो मुझे E1 नहीं चाहिए, मुझे E2 दिए, क्योंकि मैं E2 पे काम करता हूँ. Right. So this is again hodgepodge, because if you imagine sort of expanding this to like 20 services, 30 services, it becomes a mess, because everybody is just asking each other, bro,
it's too tightly coupled, right? It's too tightly coupled and everything is basically not movable. The architecture is not movable.
Just imagine the guy who's like sitting here doing S1. He's like, S2 को ये चाहिए तो वो भी बनाओ, S3 को ये चाहिए ये भी बनाओ. So he's not simply thinking about his service anymore. That's the key point here. He's thinking about both services. So that's the problem. Now coming to what we are envisioning as the event sourcing model, the core of the event sourcing model is that, okay, there is some gateway from which the request comes, right? That gateway is responsible for emitting domain events. It's like, okay, user has come, okay, so here it will emit a domain event which will be going to a central bus. This is a central bus that everybody knows.
Yeah.
And over here it is sending domain events. That, okay, domain में कुछ ये हुआ है. Anybody who's interested in this has to build any use case on top of it, will be informed. So for example, S2 might be interested in this, S3 might be interested in this. They will use that, and they will use this event without this guy telling them to use this event, because this event has been designed by an architect and informed to everybody that this is our domain event, this is the event we work on, so this is the event that is going to come when this activity happens. this is the event that will come to you.
Yeah.
So if you want to do anything with this particular situation happening in the domain, you do that based on this event.
It's like an architect building a massive building, right?
Yeah.
उसने पूरा टेम्पलेट बना दिया, ब्लूप्रिंट बना दिया है कि मैंने ये पूरा डोमेन को स्प्लिट कर दिया है इवेंट्स के अंदर.
Yes.
I have split those events out. Now these guys, I know from, because I am the architect, I know that these guys are going to be needing these domain events. So I will basically create a charter of sorts right from the word go, and my driving service itself will basically dictate that charter. That these services, whenever they are ready, you first need to consume these events and then move on to whatever else you might want. लेकिन वो, I am not putting any dependence on the service itself. I am basically saying the driver will basically do this.
So just to sort of illustrate that,
Yeah.
when S2 is, so say for example the architect decides, okay, we need S2, another service. So that guy simply tells the S2 guy, okay, you will receive domain event 1, domain event 3, and when you do your activity, you will proc this domain event number 4. This is your job. Forget about everything else. So he doesn't have to tell, oh, देखो एक event बनाना है for that other guy, you know, S3 वाला guy, and remember that other guy you have to make another event for. No. There are centralized events that you are supposed to consume and centralized events that you are supposed to generate. So you just do that.
Listen on the queue. If you detected D2 and D3, consume, do your stuff, emit to D4.
Precisely.
Done.
And the art of it is in the definition of this event. Because if this event is a nicely designed event, it will in the future be used by other services also. Like, oh, okay, I can, if there is something called D3 and D4, then maybe I can do some work here in S5 and create a new domain event called D5. You know, and I can talk to my architect and be like, I think this makes good sense. The architect might say, yes, D5 makes sense, a good domain event, and we can do it very easily. So let's do this service.
See, but if you think about it a little more intricately, you can remember what we talked about is that product can come up with new features.
Yeah.
New features could basically be broken down into multiple services. Again, domain events are not going to change.
Yes.
Because your domain is not really changing. Once your domain events don't change, you can add in and remove services and services related to features as and when you want. And that is exactly what has been shown over here as S5, right? S5 is a new feature that is coming in.
Yeah.
There is no service that is coming in because of a new feature that has been introduced in the portfolio.
Yeah. And it makes prototyping super easy.
Absolutely.
Like this guy is not disturbing anybody. He's not asking another guy, bro, I'm creating an event for you. Update your code. He's not doing any of that.
CI/CD, merge, code, merge, all that is out of the, we don't need it.
Yeah.
Not anymore.
Exactly. So this is where this, paying some attention to your domain events can really be a huge benefit to you.
Yeah.
And people can, prototype. Product team people can also come up with, sit with a team of engineers and be like, bro, listen, we have these event streams. I think we can combine them and do something. And they can just sit and do that without bothering anybody.
Correct.
And they can have a prototype ready and they can then propose that we include this into our product portfolio.
Right.
So it makes things very easy to sort of move around. Right?
Again, like you said, the name of this entire game is Atomicity and Idempotency.
Yes.
Nothing without this really works. But as you can see over here, this will ensure atomicity and idempotency because the architect has very clearly designed, number one, designed domain events to its natural granular state. Number one, and that itself ensures atomicity in the first place. And two, because he has said that for this service is responsible to consume this and then do this. And think about 10 different services all coming into that entire architect's vision, saying that all of these services will interact in so and so way, consuming so and so, producing so. All of that has been charted out and layered out in front of them. That basically ensures that at the end of that entire operation of all services, idempotency is maintained, the state or that particular event is maintained.
Absolutely.
Or the right states are basically carried forward.
I think this is a great, I think now we can straight away go into the problem of event sourcing.
Yeah.
Right? So what does, on top of this, I think this has been made clear.
Yeah.
Now on top of this, what does this event sourcing add? Right? So event sourcing, one of the major central concepts is that you have a centralized bus and you have domain events. But it introduces one additional constraint on domain events, which is that if I have a bunch of domain events here, right, in a timeline, sort of you can say that time is moving this way. So you have all these events. If I at any given point take a snapshot, right? And I run all these events, and I populate all my state source based on these events being consumed by multiple services in the middle, right? So -1, S2, S3, and my state stores ultimately get updated, right? Based on this. Every time I do this, my state will be exactly what it was supposed to be at this point in time.
Yep.
Right? So this is the additional thing that it imposes on domain events, that when you're designing domain events, you should design them in this fashion that I can time travel my state. It's kind of like that, I want to see all, like Git does, Git has like a very good way for showing you the entire history of the document, right? So you can simply replay all commits and you will get the exact same file at any point, right? That's exactly what it also imposes, that the way you design your event should be such that if I replay those events, it will always come to the correct state at that point in time.
The textbook definition of idempotency in the first place.
Exactly. Now, so इसमें implicitly, like you said, there is a need for idempotency, because if I play this event 5 times, 10 times, it should not be like this database में बढ़ते जा रहा है. It should exactly come to the same state. So which is where the requirements of idempotency also become important, right?
Correct.
Which is, I think, for any person who has ever spent their time trying to convert a non-idempotent event into an idempotent event would know that it's not always obvious how to do this.
It's
quite a lot of effort. So it's not, event sourcing for that reason is, a little bit tricky.
Yeah.
Like if you're going to invest in it, you have to really make sure that you are, buying into it fully, and you're spending the amount of time necessary in this phase, the design phase of your application. So the way sort of event sourcing shifts the development process is that it shifts it towards the design. Like most of the work is happening in the design. And implementation is simple, which is great for us because debugging becomes simple because implementation is simple.
Correct.
But if you make problems in your design, then it's a big problem.
Yeah, it's a big problem.
And so that's the sort of catch in this design. So 100% event sourcing, I don't think even we are advocating that, but we are trying to do our best in terms of like, okay, as much as we can as a guideline to our architects, our principal engineers, we are saying try to be idempotent, try to achieve this as much as you can wherever it is possible. Where it is not possible, try to do your best, like closest you can get, and maybe you want to add some logic into services for handling certain situations. And you do it in that way, but at least make it clear that okay, these events are idempotent, these ones are not idempotent, and you need to be very careful while processing these events, because if you just process them twice, bank balance 10 से 10,000 हो जाएगा. So we can't do that.
Correct.
So and then maybe at a later stage we can apply our heads to it and figure out another idempotent version of the same event, and then migrate to that new one.
Correct.
Over time. But not right now. We want to move fast. We don't want to get into the intellectual pursuit of idempotency and mathematics, category theory and all that stuff. We want to get into like, okay, we want to deliver things to our customers at the end of the day. So if something can be done fast, makes sense, so we do that first, and then we think about the niceties of the architecture. So this is one of the major things that event sourcing introduces. And then the way sort of the system works is like you have all these gateways, right? And they are all sort of introducing events into your central bus. You have all these platform services. They have their own stores, all of them independently scalable, right? And they read from these events that come. They can come across in terms of Kafka, different topics they can come from. So they're reading to all these topics, and they're updating their states, materializing their states based on this. So all your history is here in one central place, and all your current state is here. So you have both, which is in our use case absolutely crucial, because you want current state for instantly serving API requests, right? Yeah. And if you want audit, we have the entire history also. So depending upon how much we want to persist, you can say like 3 months, and we can give you a 3 months history of why the current state is like this. Okay. So this is something that we are trying to now do in our version 2 of OFRS. One of the things, we are doing many other things, but this is one of the main central sort of pieces of designing our architecture. in this sort of way.
You want to talk about the Saga pattern as well? How
Yes.
to that fits over here?
Yes. So this is the other problem that you mentioned earlier, which is the problem of atomicity. Now, we haven't purposefully addressed that so far.
Yeah, left it out. Leave the best for the last.
Yeah, exactly. So now, since you have state separation and you have the central bus, which is great, which is a good starting point, right? But there's still scenarios where you want like 3 services or 2 services are necessary, right? 3 or 4 domain events need to be simultaneously processed. I should say it in that way rather than using the word service. So 3 or 4 domain events have to be processed, and a couple of domain events need to be generated for a particular feature or user story, I would say, to finish.
Right.
But there could be some requirements on atomicity and transactionality. Right?
Yeah.
Okay, these two have to happen together, or they should be rolled back. Stuff like that. So we are now getting into the domain of rolling back. Which let's bring back the monolith. In the case of a monolith, is a breeze. Like there's absolutely no problem there.
It's a brilliant feature to have because it takes away so much pain.
Exactly. You don't have to think about it, or the database does it for you, right? So
if you want to take one massive benefit of monolithic architecture, take this.
Yes. This is so like if you are not sure, stick with monoliths because it solves the hardest problem very easily. Right? So now comes this problem. Now that state separation has happened, all these services have their own stores. So now individually these services can utilize ACID. They can have internally atomicity guarantees, but across services, guaranteeing atomicity is difficult, right? Now you are back into that domain that you no longer database no hand holding from the database anymore.
Yeah.
You as an engineer have to build atomicity into your domain event processing.
Right.
So how to do that?
Yeah, because your data store is very, very specific only to that particular state and just acting as a store, nothing else.
Right, exactly.
Nothing more, nothing else.
Right. So now what happens is that since we have this now in this paradigm, what it will look like would be, say for example, some gateway 1 has issued an event, right? And it creates this event into, let's just call it E1, into this bus, right? Now somebody might consume this event, right? Because this is the way we now operate. We don't know what is going to happen. Services know what they need to do. So they just do when an event happens. So it's kind of like real life. Stimulus happens, we do something, right? So this is a stimuli. Now somebody is going to respond to it. Maybe a couple of services will, right? So now say for example, service 1 responds to it and it generates a new stimuli, right? It generates another stimuli into our system and oops, too smart this software. So anyway, I'll just proceed. So this guy is basically generating another stimuli over here for us, and it's saying just for the sake of illustration, I'm going to just copy it here, and I'm saying okay, there's E2 also here now, right? And then some service is going to respond to this stimulus. So some S2 is going to respond to this, right? And ideally, the way it should be is that either you both respond and generate maybe this guy generates E3. Either you both do your job and then generate E3. E3 should only happen when corresponding E1 and E2 have happened.
Right.
Or it should not happen at all.
Yeah.
Right? So how to do this? Right? This is a classic problem. So one of the ways is that we somehow again go back to our initial easy stuff, which is that S1 somehow tells S2, bro, wait, I am doing E1. Then I'll tell you when to do E2, and then you can do E3. Okay? So they are directly communicating with each other in some way. But obviously we don't want to do that. We want to keep that decoupled nature, and we want to ensure this, right? So, and the other reason we don't want to do it, which we discussed I think yesterday, was that if we have to do this every time, then all engineers who are involved in making these services have now got to control the atomicity logic across services.
Yes. Each service.
So every engineer involved in any of those use cases needs to know कि bro ये sequence of operation ऐसे
which automatically means he needs to know what other services as well.
Yes. Which is what we wanted to avoid in the first place. Right. So वो problem को avoid करने के लिए is the pattern that I think Prashant you were saying, which is the Saga pattern that comes into play. Again, a very well known pattern, but still very new. Not many frameworks support this out of the box.
Yeah.
But you can write a simple framework to support this. So the way this operates is like start shifting the responsibility of maintaining transactions to this guy. who will then become the Saga owner. So what is a Saga?
Yeah.
I guess we need to get into.
Yeah, absolutely.
So basically, Saga is a user story.
The story.
Yeah, it's a story.
Story.
Something needs to happen, 3 or 4, 5 steps, right? So in our case, it would be 4, 5 domain events that need to be processed.
Call the Saga owner as a director of an entire movie, right?
Yeah.
So, I mean, he knows the actors, he knows the villains, he knows the people who are participating, etc., etc. He knows these guys coming after these guys coming after these guys interact. इसका ये होता है, वो होता है, picture खत्म.
Exactly. Nice analogy. So yeah, exactly. So this is kind of like a director, an orchestrator. If you know, we like the word orchestrator more than director. So the orchestrator, the Saga guy, his responsibility or her responsibility is to ensure that okay, I need to process E1, E2, and then I need to have E3. And if I don't receive E3 or there's a failure in the interim, I have to roll back E1. So what does he do? He basically listens on, creates this sort of saga. Says my saga is, let's just say, I have to process, you could say promotion. Some kind of promo code करना है, कोई बंदा register हुआ है on your platform, और जिस बंदे ने उसको register कराया उसको कुछ promotion देना है, right? So either they both have to happen or none of them have to happen. I know it sounds very stupid, but just for the sake of it, something like that is happening. So there's two processes that need to be done. So it will issue the domain events for those two processes. So the D1 and D2, it will create issue, and against D1 and D2, it will also map a Saga ID, which will be SID, and this will also have its own SID mapped to it. So this it is going to send across into our bus. And the same thing will happen that we described over here. Everybody is going to process their thing, but they are now processing everything against this Saga ID event.
Yeah.
And they will be generating their respective events, E1 and E2, against this Saga ID. So these are now no longer E1 and E2, they are E1 SID1, E1 SID2 SID2. And correspondingly, there should be an E3 SID3. But if something fails, what happens? Okay, if success, very clear. Okay, success ho gaya, E3 aa gaya, we generated E3, we gave a response to the user. When something fails, the rollback is also initiated by this guy. It's like he generates rollback events, like rollback this domain event, right? So rollback D1 SID1, it will say to this guy. And now the owners on these service developers, again we have simplified the problem is, when you are developing the service, you don't need to know about everything that is happening.
The owner is going to tell you.
The owner just provides a method to do rollbacks. आप मुझे Saga ID और event बता दो, उसको rollback करने का method मैं लिख दूँगा. I don't have to worry about.
I have a simple mutually exclusive atomic function which is going to do a rollback.
Yes.
So,
we can make this an architecture pattern across all our services.
Correct. You are the orchestrator. You are saying that from you have painted a whole picture for me, saying that E1, E2, E3, E4, E5 need to get done. Now and then you basically have also written a rule that if anything fails in between at checkpoints, I have defined checkpoints. If by E3 everything is successful, great, move on. If by E3 something fails, roll back the entire bloody thing.
Yeah, exactly.
And so on. I'm talking about a sample pattern, but that kind of pattern is what the Saga owners would write.
Exactly right. So the idea is that we are bundling these things inside a tag, which is the Saga ID. And because of that, we are able to ensure that, first of all, shift the responsibility to a central place. So all the people don't need to know everything. Only the person who's designing this final user story has to interact with those and get it done. Second thing is, rollback is also initiated by this guy. So if you have any bugs or issues, you know where to look. Okay, यहाँ से rollback नहीं आया तो मैं कैसे rollback करूँगा? And the service on the other side का implementation remains simple. I'm still consuming events. One of the events is a rollback event. And that rollback event basically says is domain event को rollback कर दो bro.
I am going to get input from the owner as function parameters. The Saga ID, this event, rollback. So
very simple and universal. Every service we can actually have a centralized
library.
A library that ensures that you have to implement a rollback.
A rollback library है जहाँ पे everyone will basically just call that function in the library. Done. Life becomes so much easier for developers and engineers. And reusability in components becomes massive.
We will sort of enforce कि okay, abstract class है, you have to implement it.
Correct.
Provide your own rollback.
Exactly.
That's up to you. How do you roll back? ये तेरी responsibility तू देख ले. Maybe in your rollback you don't want to do anything, you just want to delete the entry. In your case it makes sense. So you do that. Your service ke liye whatever works best.
Fair enough.
As long as your service correctly represents the data.
The core name of the game is that the developer is now going to be able to take his own decision as far as the service is concerned.
Yes, exactly.
I don't want to preach to him.
Yes.
I don't want 10 people preaching to him. The poor guy, he will do it on his own.
So in a way, if you think about it, it's like laying a communication framework. Like
very democratic framework.
Yes. That I am democratic and free in the sense that like there's no one person who's like, oh my god, I have to now think about 10 things. Like you are on this, you think about your thing, I am doing this, I'll think about my thing, and we'll communicate it using this central language that we have built. It's kind of like a domain language that we are building, that we are communicating in.
No, but talking about all this, actually sounds quite beautiful. We actually speak about it. It sounds beautiful. It sounds like Nirvana. Now, as we know about Nirvana, it is probably very difficult to achieve.
It's very difficult to achieve.
So
we have our work cut out for us. We have to do a lot of work, and obviously we will not be able to achieve it everywhere.
But as you can possibly see over here, there are bits and pieces that we don't have to adhere to all of these standards strictly. But if we only adhere to the standard of providing independence and at the same time providing integrity and idempotence, that is all that we want to achieve. अगर वो थोड़ा aggregate करके भी पहुंचा दिया, it's still okay.
Yeah. So one of the great benefits of this is that some services can read off of a separate Kafka topic and do their job without requiring them to think too much about the architecture. Because they could be experimental, like we don't even know if this feature is going to be used by anybody. Why am I making so much engineering effort into delivering this? So forget about that. But wherever we are solid that we know this feature is very heavily used, we do our best to move it into this paradigm.
And wherever we know the story deeply in our head, then I can translate. That's great.
And one of the great things about this is going to be because as it is a very repeatable sort of consistent pattern, you can, once you have the initial tooling set up, and all the developer tooling set up, then starting a new service or something like that will be...
It's like a building block, right? Lego
Exactly. So it will over time start giving speed. And so it might be a worthy investment in the beginning. आपने थोड़ा time spend करके बना लिया. Once you have this, then you are very smoothly.
And typically to our business and the way we function, right? Because supply chain, FMCGs, FMEGs, agri-businesses, they are vastly different businesses with vastly different supply chains.
Exactly.
And the functional domains are so bloody different. One feature is just is not going to make sense for another company at all. So we cannot have a standard platform as a service or a software service in any case. With this kind of a pattern, it becomes beautiful. It's basically all you need to do is someone to understand that particular business, translate it into a saga. And that saga is basically built out into a number of services which can be built independently. Some of them we might already have.
Yeah, exactly. That's the point.
Some of them we just have to reuse them, and then other small ones we need to basically fit and build.
Precisely.
Deployment is a breeze.
Yeah, and I think
not a breeze, but
in a sort of side effect of this is also that for the architect, it is much easier, or like principal engineer, it is much easier to reason about things. This is precisely what I need to do. Rather than being on a blank slate completely with no framework.
Correct.
He knows, I have to write a saga and I have to have some domain events that I am processing.
Yes.
Maybe I need to capture a new domain event. Maybe I need to generate a new domain event. So he knows exactly his to-do list. Rather than an architect, just with a blank canvas.
His only work is actually drafting that saga out. And then drafting the saga is basically a combination of two things, right? Defining domain events and connecting those domain events in a story.
Yes.
And that's a job. And the rest of it is basically translated into either services which are already there or services that will be little.
Which is, I think, one of the major things that we sort of solved here in this pattern is that, there's no blank slate. There's a set framework within which you are able to operate. And anytime, like you said, anybody has to add something new, they have to follow this to-do list, kind of like a playbook.
Yeah, a playbook.
And unless you're doing like totally innovative shit that is like not at all in this domain and you are like some genius guy, Otherwise, everything else is going to be that. And for our domain specifically, because like we said in the beginning, we are trying to become a platform. So right now we have several ERP integrations and external API integrations, and eventually we want to get to a point where we have lots and lots of APIs on our platform for other companies to build their applications on top of us.
Yeah.
So in order to enable that, having to deal with each integration individually, each individual kind of use case individually, without any bedrock framework, is going to be very difficult to manage.
It's a nightmare. We can't even we're not going to be able to visualize it at all.
Exactly. If we have this, at least we know this is a specific saga that we made for this kind of integration.
Yeah.
So it's very clear how it is going to operate. It's very clear how we are going to see the data flow. And another side benefit is because everything is tagged against the saga ID, you can track individual stories against all events.
Right.
So जो आपको Jagger वाला requirement है,
audit is completely taken care of.
Exactly.
Yeah.
All audit is already in place in that central bus.
Yeah.
आप अपना retention factor जितना मर्जी रखना चाहो आप रख लो. That's up to your cost. कितना पैसा.
Have another consumer only as an audit consumer that you want to just consume, and because why do you want to consume? Because you just want to audit it.
Yeah, and even like POCs. Like you want to do a new POC for a OLAP store, some service guy. No problem. Here's domain name stream. You do whatever you want to do.
Consume.
Yeah, you do a demo and see if it works for you. Maybe you want to switch it out.
There is no dearth of, there is no limitation on the number of consumers you can put on a topic, right?
And you can actually replay. So you can say मेरे को data migration करने का है, कोई बात नहीं, तुम current store से migrate कर लो, वो भी नहीं करना है, तुम्हें कुछ नया बनाना है, replay कर लो, सारे events replay कर लो और तुम अपने पास रख लो. It will take some time, but at least you will be consistent with the rest of the system.
Yeah.
You can do live migrations very easily.
Yeah.
You can just listen on a stream and do live migrations, that kind of stuff. So lots of other things, other benefits to this. But what we were mostly interested in was like solving this, becoming a manufacturing platform, this supply chain platform,
and taking it down,
and having not forcing specific use cases on companies, but being nimble enough that we are able to cater to many use cases. Because let's face it, since we have digitized the asset, our UIDs are on the asset. People will want to use those UIDs. They're not like मैं उससे के साथ काम कर रहा हूँ तो उसका UID लगाऊंगा, तुम्हारे साथ काम कर रहा हूँ तुम्हारा UID.
Correct.
So it has to be like, okay, on the O4S UID, everybody should be able to build their use cases.
Right.
Many of which we will capture, but some of which we will not be interested
in. And I don't want to do it specifically for every specific client. नहीं तो फिर as a product company or service company में difference नहीं रहेगा.
Exactly. So I want to be moving really fast, giving the feeling of those companies.
We are a product company.
Like we are a service company, but actually we are internally a product company. So उनको feel ऐसा होना चाहिए कि उनके पास एक बंदा है O4S में, but actually में अंदर ऐसा कुछ नहीं है. अंदर we have a really nice architecture sort of. So I think that's a really nice sort of conclusion.
Hopefully you've done
some justice to this topic.
Some justice to the story. Any questions? Any thoughts? Any suggestions? Please reach out to us on email address that is going to be provided soon.
Maybe in the description or somewhere on the screen.
And subscribe. And what?
And subscribe and like and share and everything that is supposed to be done. Do that.
Alright. Thanks guys.
Thank you so much.